Hello everyone, my name is Julia, and in this video I'm going to be solving for this problem. And this problem says calculate the volume of the following solid. The base is the region enclosed by y is equal to x squared and y is equal to 3. The cross sections perpendicular to the y-axis are squares. So to demonstrate what this problem is saying, I'm going to draw or graph out this problem in two-dimensional and three-dimensional. For the two-dimensional, we have x and y-axis, and if we draw the base, which is enclosed by y is equal to x squared and y is equal to 3, it would look something like this. If this is a graph of y is equal to x squared, and here is 3. So that means that the base is a region, this is a region that the problem is talking about. And of course, here would be square root of 3, and this here would be negative square root of 3. Since that's when the y-axis would be equal to 3. That's not really even, sorry. It's still quite not even, but whatever. Okay, so now I'm going to try to draw it in three-dimensional. I'm not the best at it, but I'll give it a try. So x is equal to square root of 3 would be, let's say here. And x is equal to negative square root of 3 would be here. So that means that 3 would be like here. Y is equal to 3. And if we draw out this graph, it would look like this. Y is equal to x squared. And the line y is equal to 3 would be this line. And the cross sections perpendicular to the y-axis are squares, so it would be perpendicular to the y-axis. It would be parallel to the x-axis like it is here. And so, okay, I'm going to draw the square in blue. So I guess this would be kind of like what the square would look like. Remember that the sides are the same, the length of the sides, and it's a square. And I'm going to go back to here, because I just did this to demonstrate it. Okay. I'm also going to draw the square here. It would be inside y is equal to 0 and y is equal to 3. And I'm just going to draw the square kind of like this. And of course the square wouldn't actually look like this, right? The square would like come out kind of like this. And that's why I drew it in a three-dimensional to demonstrate it for you guys. Okay, so it's not the best drawing, but this length here would be square root of y, right? Since this length is x and x is equal to square root of y. And the same would go for this length. And using these two, we can figure out that this whole length, this length, is equal to 2 times square root of y. And so we now figured out one of the sides to the square, right? And so we can find out for the area of the square. But what we're actually trying to find is for the volume of the following solid, and the volume is equal to the integral from, we're going to be doing it in terms of y, so dy, since the cross-section is perpendicular to the y-axis. And the interval would be from 0 to 3, since that's where the base is enclosed. And what would be the integrand? Well, the integrand would be the area, dx. And since dx is the area of, ax, since ax is equal to the area of the square, and one of the sides up to the square is 2 times square root of y, the area of the square would be this squared, so 4 times y. And let's just rewrite this. This is equal to 4 times the interval from 0 to 3 of y dy. Now let's actually calculate for this integral. The integral of y is equal to y squared divided by 2, but since we have the 4 and here, so it would be 4 times 1 divided by 2 of y squared from 0 to 3. This is equal to 2 times y squared, so 2, and we put in the 3 and we have 9 minus 0 squared is just 0. And simplify this more and we have 18 as our answer. Okay, so I hope that made sense to you guys, the way I solved for the volume of this solid. And this will be the end of the video. Thank you for watching, everyone. In this video, I solved for the volume of this solid when the base is the region enclosed by y is equal to x squared and y is equal to 3. The cross sections perpendicular to the y-axis are squares. And for the volume, for our final answer, we got 18. Thank you for watching, everyone. Bye.